storage on fast cloud storage. You can set up and deploy a new database in minutes, and you can run queries across petabytes of data. And if you want real-time processing of streaming data, you can use Amazon Kinesis, which has become a key service for IoT applications. Kinesis makes it easy to collect and analyze real-time streaming data, so you can get timely insights and react instantly to new information. Today, we have a family of Kinesis services: Kinesis video streams, Kinesis data streams, data firehose, and data analytics. So, with AWS's broad and deep portfolio of analytics services, customers are getting more out of their data than ever before. And companies are starting to really see the value in bringing all that data, which has been stored in different silos, together into what is called a data lake. Today, customers are running more than 10,000 data lakes on AWS. S3 is the #1 choice for data lakes, and there are a few key reasons why. First, S3 offers the best durability, the best availability, and the best scalability. Only S3 replicates your data to 3 availability zones inside of a single region. S3 has the best security, compliance, and audit capabilities. S3 offers object-level controls at any scale. You can do object tagging, tiering by prefix or tag. You can apply lifecycle policies to tier groups or objects, and you can do cross-region replication. S3 gives you business insight into your data. For example, storage class analysis analyzes your storage request patterns and provides recommendations for setting tiering to lower cost storage. And AWS offers many ways to bring data into S3, which we discussed earlier. And once the data is there, you can use Amazon Redshift Spectrum to connect directly to your S3 data lake and analyze exabytes of data without loading or doing ETL on that data. But setting up a data lake has traditionally been hard to do. Turns out there's a lot of steps involved in setting up a data lake. First, you have to set up your storage. Then, you have to move your data to your storage. Then you have to clean and prepare your data. Then you have to configure and enforce policies on who should have access to the data. Then you have to build tools to make your data available to your users with the right policies. And each of these steps involves a lot of work because it has to be done manually. Customers can spend months building data access and transformation workflows, mapping security and policy settings, and configuring tools and services for data movement. Customers want an easier way to do this, and that's why we built AWS Lake Formation. Lake Formation helps to build secure data lakes. First, you identify existing data stores in S3 or your relational databases. Then, you move your data into the data lake. Then it crawls, catalogs, and prepares your data for analytics. Then, it provides your users secure access through the analytics tools of their choice. Other AWS services and third-party applications can also directly connect to your data lake. Lake Formation manages all of the tasks shown in the middle of this box for you. So it massively reduces the amount of time that's necessary to set up a data lake. So I've talked about the breadth and depth of AWS as the how for customers migrating to the cloud, building new applications with microservices, achieving database freedom, and using the right analytics tools for the right job. Now, I'd like to introduce Sergey Shetov, Head of Engineering Cloud Infrastructure at Traveloka. Traveloka started with AWS on day 1 and has used a broad and deep set of capabilities from AWS as it has grown and expanded its business over the years. Traveloka offers a wide range of travel and lifecycle services that empower people to discover the world. Sergey.
Thank you, Peter, and thank you, AWS, for inviting Traveloka to be part of this keynote. It's a great pleasure to be here. Quick introduction, my name is Sergey Shvetsov. I'm the head of engineering in charge of cloud infrastructure at Traveloka. I've been lucky enough to have a very exciting IT career that started about 20 years ago when I immigrated from Ukraine to Canada. And since then, I have worked in a large variety of roles with many, many different industries and with customers from many countries and continents. Around 2010, in search for more challenges, I relocated to Indonesia, where in 2015, I joined a startup called Traveloka to lead their infrastructure, DevOps, and SRE teams. So in case you haven't heard of Traveloka, we're a technology company with a mission to enrich people's lives by empowering them to discover the world around them. Traveloka provides a very wide range of services that include travel and lifestyle experience in a single platform. Now, allow me to tell you a bit about our history and how AWS has been our partner and allowed us to solve a variety of challenges from day one. Traveloka was founded in early 2012. Our team was just about 8 people at a time, and our mission was to help people move in, out, and within the Indonesia. Our first service was just a flight meta search to help people find local airlines online. At the time, really all we needed is a fast and reliable infrastructure, but something that did not require a lot of upfront investment. And this is where AWS EC2 was just the right service for us. About a year later, in addition to a search, we added booking and payment. So we became not just a search engine, but also a flight booking platform. Around that time, we just added that capability on top of our existing apps. So in order to scale, really all we needed to do is to increase the size of our instances that were hosting our application and databases. A year later, we've added hotel booking, and we've also launched our iOS and Android applications, becoming a full-fledged travel booking platform or online travel agent, OTA. This time, we decided to scale horizontally. While still adding the capabilities to our existing monolithic service, we decided to add more instances to load balance the traffic to our larger group of backend instances. We also started to experiment with S3 and CloudFront by shifting our static content to the AWS Cloud Content Delivery Network. 2015, our app hit 1 million downloads. We've got more international airlines. We've been awarded 2 top brand awards in Indonesia, and our team already has grown to about 600 people. 100 of them were engineers. This was the time our monolithic architecture started to show signs of problems. We had many, many engineers updating different parts of the same application, deploying it to the same infrastructure at the same time. We started to have a bit of reliability issues because of all that shared infrastructure, shared code base that's been constantly modified. So that was around the time we decided to try a new approach, microservices, which you heard Peter talk about earlier. For that, we needed to scale out and break down our application into many load balancer instances, many application instances, many database instances. We also need to connect all of that together, discover the services. So luckily, AWS had just the right tools for us at the time in the shape of elastic load balancers and Route 53. In case you don't know, it's a very reliable, very inexpensive managed DNS solution. 2016 was a really big year for us. We expanded into 6 largest Southeast Asian markets: Indonesia, Singapore, Thailand, Vietnam, Philippines, Malaysia. Our app reached 10 million downloads. On the back end, however, we were struggling to manage our constantly growing fleet of MongoDBs. So we wanted to explore a managed service. Comes the relational database service and our shifts to Postgres. Around the same time, we started building our data lake and data pipeline on top of Kafka, Redshift, and S3. And we put a lot more focus into security. So we took and made better use of tools like VPC, CloudTrail, Config, IAM, and Amazon Certificate Manager. 2017, more products. We've added train, we've added flight and hotel packages, local and international data top-ups, attractions and activities. Our app has hit 20 million downloads, and Expedia publicly invested in us, officially making us a unicorn in Indonesia. Meanwhile, we've expanded our tech office to Singapore, and our engineering task force has grown to 300 people. This was a time for us where we decided to focus on speed and reliability. So we once again looked to manage services like Elastic Cache to offload, to reduce the workload on our backend services, Elasticsearch to reduce the latency of our autocomplete and location searches, DynamoDB as an inexpensive, reliable configuration store for our apps, and SQS to further decouple our microservices. In 2018, we've added our first culinary product called Eats and our alternative payment method called Pay Later. We've also, we're very proud to become a media and broadcast sponsor for the 2018 World Cup, FIFA World Cup in Indonesia. And our app has hit 30 million downloads. So at this point, we had a lot more teams, a lot more products, a lot of services and microservices, and we were starting to have issues with the operational overhead we spent on our large self-hosted CI/CD platform. We decided to break it down into smaller parts, lightweight, inexpensive, self-managed pipelines built on top of code build and code pipeline. We also started to reduce our cost by switching towards serverless platforms like ECS, Fargate, Lambda, and API Gateway. 2018, we turned 7 years old, and now we're focusing on improving the product suggestions and recommendations by using tools like ML and AI. As of today, Traveloka's got more than 100 airline partners serving 200,000 routes globally. We have nearly 500,000 accommodation partners in 100 countries. Our app has more than a dozen categories and has been downloaded more than 40 million times. We have about 2,500 people in 7 countries. Nearly 500 of them are engineers. At every stage of our growth, AWS has allowed us to scale our platforms, products, services very rapidly and economically. The AWS tendency to constantly create new features and services, while really hard to keep up with, gave us the tools to continue growing with a lot less effort. And we're not slowing down. This year, we announced our 7th country, Australia, and we opened a new technology office in India. And we keep hiring. So if you would like to be part of our vision, please do visit our career page. Thank you very much.
Thank you, Sergey. It's been great to be with Traveloka every step of the way. Today, there is so much buzz and talk about machine learning. For tens of thousands of customers like Liberty Mutual, C-SPAN, Intuit, Pinterest, Capital One, the American Heart Association, FINRA, AWS is how to do machine learning. However, progress isn't fast enough. Customers want to move faster. And to help customers move even faster, we keep providing more and more capabilities and tools for builders to use machine learning. We've been able to pull from a long heritage of investment in machine learning at Amazon. Whether it's our personalization recommendation engine, or the fulfillment automation and inventory management technology, or voice-driven interactions with Alexa, or our new Amazon Go stores. We've been doing this going back more than 20 years. But if we want if we want machine learning to become pervasive, we need to make machine learning so easy to use for all developers and all data scientists, so it just becomes a common part of your business. In the past year, we've seen more and more customers who are starting to use machine learning in a serious way. And the vast majority of them are doing it on AWS. including Singapore startup vSense that offers an AI-powered search platform for retail brands, which lets customers, both in stores and online, search for products using images rather than keywords. By using Amazon DynamoDB and machine learning optimized GPU instances, vSense indexes and processes billions of images, handles more than 3 million queries a day, and generates search results for their users in under 200 milliseconds. That speed, recognition accuracy, and scalability has helped vSense grow its business by over 200% in the last year. When we think about machine learning, we think about 3 layers. The bottom layer is where the experts live. It's made up of the frameworks and the interfaces and the infrastructure for the deep machine learning experts. In the middle layer, you have machine learning services that make it easy for any developer or data scientist to build models. And at the top level, you have AI services that loosely imitate human cognition. They enable developers to use plugged-in AI functionality for their applications without needing to get training data or train their own models. Let's look at each of these layers. We'll start at the bottom. If you look at the infrastructure, most deep learning that's being done today in the cloud is using the Amazon P3 instances. Our P3DN network instances provide 100 gigabits of networking. This enables developers to scale their model training performance across multiple instances, which accelerates pre-processing and removes data transfer bottlenecks that slow down their models. The largest instance type, the P3DN24XL, is the largest GPU instance available anywhere. These instances have more than 3 times more networking than any other instance. They have twice as much GPU memory as any other available instance. And they have 100 gigabytes more of system memory than any instance available from any other provider. And now if you look at frameworks, we support a very broad group. More than half of our customers using machine learning on AWS use more than one framework in their day-to-day machine learning work. Lots use MXNet for speech models and recommendations. Others use PyTorch to research new methods. And TensorFlow is often used for computer vision and language models. And if you study history, change is constant. There are going to be new frameworks, and we'll support those as well. The one with the most resonance right now in the community is TensorFlow. So let's look at that one. 85% of TensorFlow workloads running in the cloud run on AWS. Siemens runs their natural language processing model to expedite due diligence on energy projects. Beth Israel, a Harvard medical school, is building a model to accelerate identifying consent from patients and review patient records. And Snap, the maker of Snapchat, built TensorFlow models on AWS to better match ads to users to maximize revenue and engagement. Customers using TensorFlow love the availability of reference code supplied by the vibrant community of developers. But when they start training larger models, they can run into scaling problems. And that's because customers usually need to scale their training across hundreds of GPUs. The inner workings of TensorFlow make this difficult. And scaling across 256 GPUs with standard TensorFlow is only 65% efficient. So we spend time innovating on the way that TensorFlow shares parameters and information across multiple instances to overcome the scaling limitation. This significantly improved the scaling efficiency up to 90% over those same 256 GPUs, allowing customers to train twice as fast on the same GPUs. That's great for training, but what about inference? Running inference in production actually drives the majority of cost in any machine learning workflow. And this just kind of makes sense. You train a model once, maybe twice a week, but in that same time period, you may run thousands or even millions of inferences. Alexa's a great example. We regularly retrain our models to make improvements, but every Alexa request from a customer contributes to the inference. So to help reduce inference costs, we created elastic inference and inferentia. Elastic inference allows you to use smaller general purpose instances like the M5 and provision just a little bit of GPU for your application. And inferentia is a high-performance machine learning inference chip developed by AWS. It will provide hundreds of teraflops of inference performance. Multiple inferentia chips can be used together to drive thousands of teraflops of performance on one server. It will also reduce the cost of inference by as much as 10x, even compared to elastic inference, which means huge savings for inference at scale. Elastic inference is available today, and inferentia will be available later this year. Now, while we're seeing a lot of activity at this lowest level of the stack, the reality is there just aren't that many machine learning experts in the world yet. We're training more of them in universities, but there just aren't that many. So, if you want to enable most enterprises and companies to be able to use machine learning, you need to solve the problem of making it accessible to every developer and data scientist. And that's why we built and launched Amazon SageMaker. Amazon SageMaker is a managed ML service in the middle tier that makes it easier for everyday developers and data scientists to get up and running with machine learning. Right now, you can get going with a single click, and you have access to fully managed machine learning notebook environment using the popular Jupyter OS format. SageMaker Ground Truth makes it easy to build highly accurate training data sets and reduce data labeling costs by up to 70% by using machine learning. Next, SageMaker makes it easier to choose and implement your desired algorithm and framework. Our teams have optimized the top algorithms to run more than 10x faster in SageMaker, and you can also bring any algorithm or framework you want. And the AWS Marketplace for machine learning offers more than 150 algorithms that you can deploy directly to Amazon SageMaker. And if you need to teach machine learning models where there is no training data, SageMaker RL allows you to build fully managed reinforcement learning models, including some of the newest and best performing algorithms. It's also much easier to do training with SageMaker than anywhere else. You specify the location of your data and the instance types that you want to use, and SageMaker automatically spins up a cluster to do training, and it spins the cluster down when it's done. Once you've trained a model, you can optimize it further in a number of ways. You can use SageMaker Neo to continually optimize your model for significant performance gains, ensuring you always have the highest performing model for the instances you're running on. And once you've tuned your model, you just pick the instance type, and you can one-click deploy it to production. Once deployed to production, SageMaker manages the compute infrastructure on your behalf. There's no more muck. Today, we have more than 10,000 customers using Amazon SageMaker. Many of those customers are standardizing on AWS for machine learning. Siemens Financial Services uses TensorFlow on Amazon SageMaker to develop a natural language processing model that reduced the time to summarize diligence documents from hours down to 30 seconds. Before using Amazon SageMaker, Siemens Financial Services personnel would need to manually review thousands of pages of documents in order to extract the relevant information. With the help of this model, that time has been reduced significantly. And in ASEAN, Sephora Southeast Asia, a leader in global prestige retail, has deployed Amazon SageMaker in 2 experimental use cases. The first is for sales and inventory forecasting. We're testing different sales forecasting strategies to improve sales tooling in an omni-channel environment. And the second is for product keyword tagging to optimize portions of the product creation process. Sephora is already reducing the time for product creation by 10% on average. Okay, so far we've discussed the bottom and the middle stack of the machine learning stack. First, we talked about the frameworks and the infrastructure used by experts. Then we talked about SageMaker to make machine learning capabilities available to all developers. Now, at the very top of the stack, we serve developers and companies who want to add intelligence to their applications, but don't want to build their own models. Customers can easily build these capabilities into their new and existing applications using simple API calls. This increases speed and improves customer satisfaction and insight. We offer a broad range of services, from vision to speech to language to chatbots to forecasting. Let's take a look at a few of them. For vision, we have recognition image and recognition video. This allows you to do things like, tell me what's in this image, or which celebrities are in this image, or is this image appropriate for work? For documents, we have Textract to easily extract text and data from virtually any document. And unlike typical OCR applications, which are not very useful when you have data in a table or data in a graph, Textract uses machine learning to natively understand the document format. So, where OCR simply extracts the text, Textract identifies the position on the page and the relationship between the text. This means for tables, it can extract things like rows and columns. And you can actually take those rows and columns and load them directly into something like your Aurora database. For speech, we have Poly to turn speech to text into speech, and transcribe if you want to transcribe audio back into text. For languages, we offer Translate for translating text to over 20 different languages. Then there's Comprehend to understand what's being said, and Comprehend Medical, which makes it easy to extract relevant medical information from documents and unstructured text. And with Lex, we offer a service that uses automatic speech recognition and natural language processing for building conversational interfaces. We also have Forecast, our accurate time series forecasting service, and Personalize, our real-time personalization and recommendation services. Both Forecast and Personalize are fully managed services, so there's no servers to provision and no machine learning models to build. And both are based on technologies used by Amazon.com. And we've also got some great resources to help you get started across the whole spectrum of machine learning services. We've got Amazon ML Solutions Labs to help you accelerate and use machine learning in your products and processes. It pairs your team with machine learning experts to prepare data and build and train models and put those models into production. We've also got the Amazon Machine Learning University, which expands upon this training and provides learning paths for key stakeholders and specialty certifications. Okay, I promised we'd end with something fun, and you've all been very patient. So I want to talk to you about a new fun way to learn machine learning. AWS Deep Racer is a 1/18th scale race car, driven by reinforcement learning, and gives you an exciting and fun way to get started with machine learning. Reinforcement learning is an advanced machine learning technique which takes a very different approach to training than other machine learning models. Its superpower is that it learns through rewards very complex behaviors without requiring any labeled training data. And it can make short-term decisions while optimizing for a long-term goal. And what's a race car without a little competition?
Hello everyone, I'm Ryan Marine. These are 1/18th scale RC cars that are fully autonomous thanks to reinforcement learning.
How cool is that? All right, here's how this works. You can build an RL model, either at a workshop right here at the Summit or at home. Then you can bring that model to the track and start racing at the AWS Deep Racer Singapore Speedway, set up just outside in the expo hall. And if you don't have a model, you have an option to pick from some standard models in our pre-trained samples at the track. You can do this at any of the Deep Racer League races at select AWS summits throughout 2019. You can participate as many times as you would like. And the winner of each Deep Racer League race and the top 10 point scorers worldwide are going to win a fully expenses-paid trip to Deep Racer League Championship Cup, which will be held at reInvent 2019. So after this session and throughout the day, please go race. Today, you're going to have the opportunity to attend a number of different sessions on services we've discussed today, as well as some we did not. And the one thing I want you to take away is whether you're a new startup, a 100-year-old enterprise, or a highly regulated government agency, you can build on AWS. We have the tools you need. With that, I want to thank you for your time and hope you have a great day here at reInvent.
Great job. Thank you, Peter. Thank you to Sergey and CK as well for an awesome keynote. Tons of good stuff there and some great customer examples as well. We've got some housekeeping to do here just to tell you a little bit about the rest of the day. And to help me, I'm going to ask for a friend. I'll talk a bit about this in a minute. So Grace, what did you think?
I mean, wow.
That's high praise. So what are you going to do through the rest of the day?
There's so much to choose from. Deep Racer, all the sponsors in the expo, the AWS booth, Startup Central, Dev Lounge.
And so what's up next?
We have a 45-minute break for refreshments in the expo hall, and then you can